All right, today we're going to be talking about graphing from the slope-intercept form of an equation. So the first thing I am asking you to do in the set of notes is to go to Desmos and just type in y equals mx plus b and add sliders to all. And I want to look at a couple things. So as I start typing in a letter that isn't x, y, or e, Desmos will ask me if I want to add sliders. And I'm going to add sliders to all. And I'm going to set this at 0, okay? And I'm going to leave m at 1. And I just want you to take a look at what happens when I change this number here. Okay, so I'm going to pull this slider up and down. Okay, I'm going to pull this slider up and down. I'm going to put it back at 0. If I set b to be 2, where is the y-intercept? If I set b to be -7, where is the y-intercept? So what does changing b do to the parent function y equals x? It moves it up and down. Moves it up and down. And you can see that with Desmos. Okay? And now let's look at, we're going to do the same thing, but this time we're going to see how things change when I change the m. So right now I have the m right here set to 1, and you may remember that m stands for slope. Okay, so maybe it stands for slope here, and this time I'm not even going to drag it. I'm just going to hit play and see what happens. So as this number gets bigger, watch what happens to this line. It's getting steeper and steeper and steeper, and steeper and steeper and steeper. Now I'm going to type in a couple things here. So if I change this number to a fraction, let's see what happens. I'm going to set it back at 1 first, and this is what we call the parent function. And we saw that as this number got bigger, this line got steeper and steeper. Let's see what happens as we turn this into a fraction. If I maybe put it at 0.75, so 3/4. But that line's getting a little flatter, okay? Let's see what happens at 1/2. It's getting flatter again. Let's see what happens if we make it a really tiny fraction, like 1/100. And you can see that as this slope becomes a fraction, this line's going to get closer and closer to a horizontal line, so it's getting flatter and flatter. Now let's see what happens if we turn this into a negative number. Well, now it's a negative line. What if it's a really big negative number? It's going to be a really steep negative line. What if it's a really tiny negative fraction, 1/25? Well, the line is still negative, but it's getting closer and closer to 0. So what happens as we change the m in the parent function y equals x? Well, bigger number for a coefficient makes the line steeper, right? A fraction makes the line flatter, closer to 0, closer to, let's say closer to horizontal, let's say h. This would be closer to vertical, let's say v. And a negative number for a coefficient makes the line negative. Okay, so this is called the slope-intercept form of the equation, where m is the slope and 0, comma b is the y-intercept. So to graph a linear equation using slope-intercept, we're going to identify the intercept, graph the intercept, and use the slope to navigate to a second point. Let's take a look at a couple of examples. Okay, let's take a look at this one to start. I apologize for the arrow that's in the middle of the screen here. Could not be avoided. So the first thing that we're going to want to do is identify where the y-intercept is. I see the number b is equal to 2. The x value will always be 0. We're going 0 up and 0 down because we want to be on this line, correct? And the y-intercept is at 2. So the first thing I'm going to do is plot that point. B is equal to 2. I'm going to look at the coefficient before the x. I see the slope is equal to 1/2 because remember the equation we're dealing with is y equals mx plus b. This is Miss B's favorite, and you're going to hear me say that over and over again. So we're looking at the coefficient here before the x, excuse me. And we're going to use that 1 up, 2 over to plot a second point and draw our line. And how do you think I'm going to ask you to check that? Well, of course, I'm going to tell you to put the original equation into Desmos and see if your picture matches it. And here is the picture when I put it into Desmos. I can go back, take a nice look at my picture, see if they match. And sure enough, they do. Let's try a second one. So again, we're looking at y equals mx plus b. B is this number here. So b is equal to -3, which means my y-intercept is going to be 0, -3, because we want to be on this line. We want to be on the y-axis. So I go 0 over and I go 3 down. I plot my first point. I'm then going to identify the slope, which is the coefficient of the x value. And the coefficient here is 2. So slope is 2. And remember that if we do not see a denominator, it has to be 1. Any number divided by 1 is itself. I'm going to go 2 up, 1 over, and navigate to the next point. And I can put more points on there if I want the line to be more accurate, but I certainly only need 1 other point. I need 2 points to make a line. So let's check this in Desmos, 2x minus 3. And here's the line of 2x minus 3. We can see it crosses the y-axis at 0, -3, and I can even drag this down so show you side by side that in fact our lines do match. Okay. Thanks for watching, and I hope this helped. This has been Slope-Intercept, Miss B's favorite. Thanks.